students of the day. In this session, we will concentrate on how to construct a root locus with an example. So, let us consider a problem statement. Sketch the root locus of a system having open loop transfer function g of s h of s equal to k into s plus 3 divided by s into s plus 2. So from the given problem statement, g of s h of s equal to k into s plus 3 divided by s into s plus 2. So initially we need to find number of branches. To find out the number of branches, we need to calculate open loop poles and open loop zeros. So in this, denominator polynomial is of order 2. So number of open loop poles is 2. And numerator polynomial is of order 1. So number of open loop zeros equal to 1. That is, number of open loop poles n equal to 2 at s equal to 0 and s equal to minus 2. This value of the poles are obtained by equating denominator polynomial s into s plus 2 to 0. Number of open loop zeros m equal to 1 at s equal to minus 3, and this 0 is obtained by equating numerator polynomial s plus 3 equal to 0. So number of open loop poles n equal to 2, m equal to 1. Therefore, the number of branches, which is the max of n or m, that is 2. And out of the 2 branches, two branches start from s equal to 0 and s equal to minus 2. That is because of root locus starts from open loop poles and terminates at one of the branch terminates at s equal to minus 3, that is at open loop 0, and other branches terminate at 0 at infinity. So out of the 2 branches starts from these open loop poles, one branch terminates at this 0 and other branch terminates at 0 at infinity. So if we plot the initial graph, this is the S plane, 2 poles s equal to 0, s equal to minus 2 and 1 0 at s equal to minus 3. So based on the rule number 3, real axis is the part of the root locus. So between 0 to minus 2, if I consider any point, to the right one pole is existing, that is the odd number. So between 0 to minus 2 is the part of the root locus. And between minus 2 to minus 3, if I consider any point, to the right 2 poles are existing, which is an even number. So this is not a part of the root locus. To the left of minus 3, if I consider any point, from that point to the right 1, 2, 3. Total 3 pole 0 exist, so it is a part of the root locus. From the starting point and ending point, these are the starting points. So branch starts away from this pole in this direction, as well as this one more branch start from this pole in this direction. As it is the open loop 0, which is the terminating point, so one of the branch terminates at this particular 0, so the direction is towards the 0. So from this we can conclude one more thing, that is between 0 to minus 2 there must be one breakaway point. The reason is because existence of breakaway point, if we consider, if 2 consecutive poles and between them is the part of the root locus, then there exists a breakaway point. 2 consecutive poles, between them is a part of the root locus. As well as a 0 and left of it, it is a part of the root locus, then there exists one breakaway point. So 2 possible breakaway points exist in this. One is here and one is here. So let us see. Let us calculate little later. So next Let us calculate angle of asymptotes and centra. So angle of asymptote for this problem is 2q plus 1 into 180 divided by n difference m, where q is 0 only. Reason is because q is from 0 to n minus m minus 1. So n is a 2, m is a 1, so 2 minus 1 is 1, minus 1, so it is 0. So only phi 1 is 180 degree. That means only one branch terminates at infinity. So the centroid sigma equal to sum of the open loop poles minus sum of the open loop zeros divided by n difference 1, n difference m. So 0 minus 2 minus 3 divided by 2 minus 1, that is 1, that is this. So it is terminating in the direction of 180 degree. So the graph remains the same because 180 degree is in this particular direction, negative real axis. So starting from this point, angle of asymptote is minus 180 degree. That indicates one branch terminates in the direction of negative real axis. So next is the calculation of breakaway points. To calculate the breakaway points, we need a characteristic equation of the system, that is 1 plus g of s h of s equal to 0. So for this particular problem, it is 1 plus k into s plus 3 divided by s into s plus 2 equal to 0. So if I take the LCM, common denominator, s into s plus 2 plus k into s plus 3 equal to 0. After the characteristic equation, I need to obtain k as a function of s. So by rearranging this, I will get k is equal to minus s into s plus 2 divided by s plus 3. So next is differentiating k with respect to s and equating to 0. So dk by ds equal to, it is u by v rule. Numerator is also polynomial of s, denominator is also polynomial of s. While differentiating, we need to apply u by v rule. So it's based on u by v rule. v du minus u dv divided by v square. So s plus 3 whole square, v s plus 3 into differentiation of the numerator, that is s square plus 2s, that means 2s plus 2 minus numerator polynomial s into s plus 2 into differentiation of the denominator, that is 1. So is equal to 0, so we can cancel the denominator polynomial. The expression becomes 0 only when numerator is 0, that is s square plus 6s minus plus 6 equal to 0. By solving this, we will get the roots are as S1 and S2 as minus 1.2678 and minus 4.7320. Both possible breakaway points are real, so we can validate this as a breakaway points by seeing the graph. So both these roots are real, so we can validate this is as a breakaway point or not by seeing the graph. So in this minus 1.28, it will come somewhere here. So which is the part of the root locus? So minus 1.2873 is this point, which is the part on the root locus. So this is the valid breakaway point. And minus 4.73. So this point, and it is also a part of the root locus. So both these points are valid breakaway points. So as I told in the beginning, there exists a breakaway point in between this and somewhere here. So according to this is the one breakaway point and this the another breakaway point. Minus 1.27 and minus 4.73. Next is the intersection with imaginary axis. So to find out the intersection with imaginary axis is by Routh-Hurwitz criteria. So to write the root table, we need a characteristic equation which is equal to 1 plus g of s h of s equal to 0. So 1 plus k into s plus 3 divided by s into s plus 2 equal to 0. So s into s plus 2 plus k into s plus 3, that is s square plus 2s plus ks. So 2 plus ks plus 3k equal to 0. So if I write the root table for this, s square coefficients are 1 and 3k, and s to the power 1 it is 2 plus k and 0, s to the power 0 it is a 3k. So in this, both all the elements of the row become 0 is possible either on this or on this. So to find the k marginal value, if I consider this 2 plus k margin equal to 0, so k margin is equal to minus 2. Or if I take 3k equal to 0, k equal to 0. So it is k margin is minus 2. But by the definition of the root locus is the variation of the closed loop poles as k varies from 0 to infinity. Only k value should be a positive value, 0 to infinity. But here it is 0 when k value is minus 2, so which is not a valid point. So by the definition of the root locus, k margin is not a valid value of the k, because k should be positive, but here I am getting k margin as negative. So root locus is not intersecting imaginary axis. So in this particular case, root locus is not intersecting imaginary axis. Next, no complex poles are 0, because poles and zeros are real open loop poles. So angle of departure or arrival does not exist. So we have collected all the points: starting point, end points, breakaway, angle of departure, arrival. Collectively, if I plot, root locus looks like this. So this is the one breakaway point, this is the another breakaway point. These are the starting branches. Two branches starts in this direction. At minus 1.27 it will take a deviation and then it reaches here. So it is not intersecting the imaginary axis. So this is the circle. So in this particular case it may not look like a circle, is because of the scaling. X-axis scale is different, y-axis scale is different, so it is not looks like a circle, but actually it is a circle. So if it is a circle, what is the center? Center is average of these two, minus 1.27 and minus 4.3, that is minus 3 comes as a minus 3.5. No, minus 3 is a center, and from that draw a circle. So this is the root locus of the given problem. We will solve one more problem in the next session. Thank you.